Good morning, students. Welcome to Bindu Dhadwal chemistry lessons. Today we'll be doing exemplar problems based on the chapter classification of elements and periodicity in properties. The isoelectronic species sodium, magnesium, fluoride and oxide ion. The correct order of increasing length of their radii is, so radius decreases with the increase in nuclear charge. So magnesium having nuclear charge 12 will be having the least radius, then sodium, then fluoride having nuclear charge 9, then oxide ion having nuclear charge 8. Which of the following is not an actinoid? So actinoids are species having their atomic number between 92. Actinium, all these are actinoids. Terbium with atomic number 65 is not an actinoid. Option D is the correct answer. The order of screening effect of electrons of s, p, d and f orbitals of a given shell of an atom on its outer shell electrons is, so penetrating effect of s orbitals is the greatest, so they cause the greatest screening effect. So s is greater than p is greater than d is greater than f is the correct. First ionization enthalpies of sodium, magnesium, aluminium and silicon are in the order. The first ionization enthalpy of sodium will be the least because only one electron has to be lost. First ionization enthalpy for magnesium will be greater than that of sodium. But if we compare between magnesium and aluminium, the electron is to be removed from fully filled s orbital in case of magnesium, whereas by losing the electron of p orbital, aluminium gets a fully filled s orbital. So electronic configuration for aluminium will be less than that of magnesium. So sodium is less than magnesium, but magnesium is greater than aluminium, and aluminium is less than silicon because nuclear charge for silicon is more, so ionization enthalpy will be more. Option A is the correct answer. Electronic configuration of gadolinium, atomic number 64 is 57 and 7, 64. So this should be the configuration of gadolinium. Xenon 4f7, 5d1 and 6s2. So we have this over here, so option C is the correct answer. The statement that is not correct for periodic classification of elements is, properties of elements are periodic function of their atomic numbers. True. Non-metallic elements are less in number than metallic elements. True. For transition elements, 3d orbitals are filled with electrons after 3p and before 4s. No, not true. We fill the electrons, we first fill the electrons of 4s and then we come to fill the 3d electrons. So option C is not correct. The first ionization enthalpy of element generally increases with increase in atomic number as we go along a period. True, because as we go along a period the atomic size decreases, so ionization enthalpy increases. Among halogens, the correct order of amount of energy released in electron gain or electron gain enthalpy is, so the electron gain enthalpy amongst halogens, chlorine has the highest electron gain enthalpy, fluorine has less than that of chlorine. So but chlorine has greater electron gain enthalpy than bromine. This is the option here, and bromine has greater than iodine. So option C is the correct answer. The period number in the long form of periodic table is equal to maximum principal quantum number of any element of the period. The elements in which electrons are progressively filled in 4f orbitals are called, so option C is the correct answer. Which of the following is the correct order of size of a given species? We know that cation is smaller in size than the atom and anion is greater in size than the atoms. Option D is the correct answer. The formation of oxide ion from oxygen atom requires first an exothermic and then an endothermic step. When first electron is entered, reaction is exothermic. On adding second electron, we have to give energy. The reaction is endothermic. Thus, process of formation of oxide ion in gas phase is unfavorable even though oxygen 2 negative is isoelectronic with neon. It is due to the fact this is true, electron repulsion outweighs the stability gained by achieving noble gas configuration. Even though by gaining an electron, the oxide ion achieves the configuration of noble gas, but because the electron is to enter an already negatively charged oxygen mononegative ion, the repulsion between the two negatively charged species has to be overcome. So extra energy is required to overcome this repulsion. So the reaction is endothermic. Comprehension given below is followed by some multiple choice questions. Each question has one correct option. So in the modern periodic table, elements are arranged in order of increasing atomic numbers, which is related to electronic configuration. Depending upon the type of orbitals receiving the last electron, elements in the periodic table have been divided into 4 blocks. The modern periodic table consists of 7 periods and 18 groups. Each period begins with the filling of a new energy shell. In accordance with Aufbau principle, the 7 periods have 2, 8, 8, 18, 18, 32 elements respectively. The 7th period is still incomplete. To avoid the periodic table being too long, the 2 series of F elements called lanthanoids and actinoids are placed at the bottom of the main body of periodic table. The element with atomic number 57 belongs to last electron enters 5d subshell, so it belongs to D block. The last element of P block in 6th period is represented by the outermost electronic configuration. Option C is the correct option. The configuration will be 4f14, 5d10, 6s2, 6p6. Which of the elements whose atomic number is given below cannot be accommodated in the present setup of the long form of periodic table? 107, 118, 102 are less than 118. These are accommodated in the periodic table. The atomic number 126, this element is not accommodated in the periodic table. Electronic configuration of element which is just above the element with atomic number 43 in the same group. Krypton 36, 5s2 38 and 4d5 43. So the element which is placed directly above this should be having configuration 3d5 and 4s2. So of these options, the option A 3d5 4s2 is the correct answer. The element with atomic number 35, 53 and 85 are all halogens. Electronic configuration of 4 elements A, B, C, D are given below. Which of the following is the correct order of increasing tendency to gain electron? So out of these 4, element A is a noble gas, so it will not have the tendency to gain electron. It should have the least tendency. So A should be placed in the beginning. Then after that, the element C has configuration as 2p6 3s1, so it has a tendency to give electron, and its tendency to accept electron in the 3s subshell will be less, so it has tendency lesser than these 2 elements. So after A, C has more electron gain enthalpy. Then out of B and D, D will have the maximum electron gain enthalpy because only one electron is needed to be filled to acquire a noble gas configuration. So this option 1, is the correct answer. Which of the following elements can show covalency greater than 4? So of these, beryllium, phosphorus, sulfur and boron, phosphorus and sulfur have vacant d orbitals. So they can expand their octet and have number of electrons greater than 8. So phosphorus can show covalency greater than 4. Sulfur SF6 also can show a covalency greater than 4. Those elements impart color to the flame on heating in it, the atoms of which require low energy for ionization. That is, they absorb energy in the visible region of spectrum. The elements of which of the following groups will impart color to the flame? We know that elements of group 1 and 2 have low ionization enthalpies, alkali metals and alkaline earth metals. So option A and C with group number 2 and 1, they impart color to the flame. Which of the following sequences contain atomic numbers of only representative elements? Now, representative elements are elements belonging to S block or P block elements. So, the atomic number 3 is S block, atomic number 33 is P block, atomic number 53 is P block, and atomic number 87 is again P block. Option A. 22 is a D block element. This is a D block element, so it does not belong to representative elements. Then C block, 25 is D block, manganese. So 9 is P block, 35 is P block, 51 is P block, and 88 is again P block. So option D also contains representative elements. Which of the following elements will gain one electron more readily in comparison to other elements of their group? Oxygen being smaller in size, it does not gain electron that easily as compared to sulfur, and down the group the tendency to gain electron decreases, so sulfur has more tendency, so sulfur gains electron more readily in comparison to other elements of the group. Then chlorine is the element which in its respective group has the maximum electron gain enthalpy. Which of the following statements are correct? Helium has highest first ionization enthalpy in the periodic table. Correct. Chlorine has less negative electron gain enthalpy than fluorine. No, not correct. Mercury and bromine are liquids at room temperature. Correct. In any period, atomic radius of alkali metal is highest. Yes, as we move from left to right, the atomic radius decreases because of increasing nuclear charge. Following set contains only isoelectronic ions. Zinc 30 with 2 positive charge means 28. Calcium 20 with 2 positive means 18. Potassium 19 with 1 electron less is 18. 20 with 2 electrons less is 18. 21 with 3 electron less is 18. 17 with 1 electron more is 18. So these are isoelectronic ions. Phosphorus 15 with 3 electrons more is 18. Sulfur 16 with 2 electrons more is 18. Chlorine 17 with 1 electron more is 18. Potassium 19 with that 1 electron less is 18. So option C, option B and C are the correct options. Which of the following options order of arrangement does not agree with the variation of property indicated against it? Aluminium ions is smaller than magnesium ion, then sodium, then fluoride. Increase in ironing size. True. Increasing first ionization enthalpy. Boron is less than carbon, is less than nitrogen, is less than oxygen. No, not true. It should be boron less than carbon, less than oxygen, less than nitrogen, because nitrogen has configuration 2px1, 2py1, 2pz1, which is exactly half filled. So electron to be removed from exactly half filled stable configuration is difficult. So first ionization enthalpy for nitrogen will be more than that of oxygen, which is 2p4. By losing one electron, it acquires a stable 2p3 configuration. So this should be the order. So option B does not, order does not agree with the property. Then increasing electron gain enthalpy. Iodine is less than bromine, is less than chlorine, is less than fluorine. No, this also does not agree with because the order for chlorine should be more than that for fluorine. That's all in today's video. Thank you. Have a nice day.